Hello everyone, so we are back again with another new topic. So the topic is straight line generators and rocker mechanism. Okay. So first we go to straight line motion mechanisms. Okay, so straight line motion mechanisms are mechanisms having a point that moves along a straight line or nearly along a straight line without being guided by a plane surface. Okay, so here you can see the figure of a condition for exact straight line motion. Okay, so here you can see the figure of exact straight line motion. So moving on to it, AB into AC locus of point C will be a straight line perpendicular to AE if it is constant. If you refer to this figure, you can see here this CE. So E here is the perpendicular, and here you can see AB, which is perpendicular at point B. Okay, so O is the center. So from triangle AEC is equal to from triangle ABD. Okay, so here you can see triangle AEC is equal to triangle ABD because they are both perpendicular at point B and at point E. Okay, so AB by AC is equal to AB by AE. So AE will be equal. So AE will be equal to AB into AC divided by AB. But here we can see AD is constant. Therefore, AE is equal to constant. So if AB into AE is equal to constant. Okay. Next, we go to peculiar exact straight line motion mechanism. Okay, so here you can see the figure of this mechanism. Here AE is the input link. Okay, so here you can see this one AE. Okay, AE, this one AE is the input link, and point E moves along a circular path of radius AE. Okay, so it will move along a circular path of radius AE is equal to AB. Okay, so AE, this one, is equal to AB, this one. Okay, also EC is equal to ED. EC, this one, EC is equal to ED. Okay, is equal to PC is equal to PD. Okay, and BC is equal to BD. So BC is equal to BD. Okay, so point P of the mechanism moves along exact straight line perpendicular to BA extended. Okay, so to improve BE and P lie on same straight line, here triangles BCD, ECD and PCD are all isosceles triangles having common base CD and apex points being B, E and P. Okay, so if you refer to the above figure, you can see that therefore points B, E and P always lie on the perpendicular bisector of CD. Hence, these 3 points always lie on the same straight line. To prove product of BE and BP is constant in triangles BFC and PFC, here you can see BFC and triangle PFC, these two triangles. Okay, these two triangles, if you consider these two triangles, here BC square is equal to FB square plus FC square, and PC square is equal to FPF square plus FC square. Therefore BC square minus PC square is equal to be FB square minus PF square. Okay, so it will be FB plus PF and FB minus PF is equal to BP into BE. But since BC and PC are constants, product of BP and BE is constant. Okay, so which is the condition for exact straight line motion? Thus point P always moves along a straight line perpendicular to BA as shown in the figure. Okay, next we move on to approximate straight line motion mechanism. Here a few 4-bar mechanisms with certain modifications provide approximate straight line motions. Okay, so first is the Roberts mechanism. Okay, So here you can see the figure of Roberts mechanism. Okay, so this is a 4-bar mechanism where PCD. Okay, so here you have seen P, C and D. Okay, so this is a single integral link. Okay, is a single integral link. Also dimensions AC, BD, this one BD, okay, and CP. So this is the point C, this is the point P. CP and PD, okay, PD are all equal. So these both links are equal. So point P of the mechanism moves very nearly along line AB. So point P moves very nearly along line AB. Okay, this line. Okay. Next is crank rocker mechanism. Okay, so in crank rocker mechanisms, what happens? The rocker oscillates between two limiting angles. In general, the crank is the input and rocker is the output. The positions of the mechanism when the rocker is at a limit position are called the dead center positions of the 4-bar. Okay, so here you can see the double rocker mechanism. Here you have seen the curves. Okay, so this is how it moves. So here you can see S plus L is less than P plus Q. Okay, so double rocker mechanism is a 4-bar mechanism. In this linkage, both the links pivoted to the fixed link oscillates. Okay, it is a Grashof linkage for which the sum of the lengths of the shortest link and the largest link is less than the sum of the lengths of the other two links. Okay, so here S plus L is less than P plus Q. So small s is equal to length of the shortest link, L is equal to length of the largest link, P and Q is equal to lengths of the other two links. In double rocker linkage, the shortest link is the coupler. Okay, so it makes a full revolution. The position of the other three links does not affect the nature of the mechanism. So here you can see the rocker mechanism. Okay, this figure you can see the rocker mechanism where this is the coupler. Okay, so here this mechanism is also known as rocker mechanism and double lever mechanism. Next we move on to transmission angle. Okay, so now what is the transmission angle? It is rather important to understand how the mechanism will function under loaded conditions in practice while the kinematic characteristics of the mechanism is being considered. Okay, so by the performance of the mechanism we mean the effective transmission of motion and force from the input link to the output link. This also means that for a constant torque input in a well-performing mechanism, we must obtain the maximum torque output that is possible, and the bearing forces must be a minimum one. Okay, so of course torque and force are not the quantities that has been in the kinematics, and whatever kinematic quantity we use to define the performance of the mechanism, this quantity will only approximate the static force characteristics of the mechanism. Okay, so the dynamic characteristics, which is a function of mass and moment of inertia of the rigid bodies, may be several times more than the static forces, and the behavior of the mechanism under the dynamic forces cannot be predicted by kinematics. Still, some rule of thumb of the behavior of the mechanism under load is better than none. Alternate define the transmission angle as tan mu is equal to force component tending to move the driven link divided by force component tending to apply pressure on driven link bearings. Okay, or the transmission angle can be defined as sin mu is equal to force component tending to move the driven link divided by total force applied to the driven link. So with this we have come to the end of this lecture. Thank you everyone.